Welcome back to our channel. Today we will discuss question number 10 of exercise 2.2. The question given is dy divided by dx is equal to 2y plus 3 divided by 4x plus 5 whole square. We will solve this equation by separable variable method and we'll find out the general solution of this given differential equation. Now if anyone who have any sort of question related to separable variable method, or if they don't know about general solution or differential equation, so they have to watch our previous videos. Now let's come to the solution of this equation. As the question is dy divided by dx is equal to 2y plus 3 divided by 4x plus 5. In first step, we will separate the power on this whole term to the denominator and the denominator separately. Just like dy divided by dx is equal to 2y plus 3 whole square and 4x plus 5 whole square. Now as we are solving this equation by separable variable method, so we will separate this term and we will also separate this term from each other. We will shift the 2y plus 3 to the left side of the equality. We will shift the dx from the left side to the right side of the equality. Like we will get here in the next step, we will get here 2y plus 3 whole square dy is equal to 1 divided by 4x plus 5 whole square and dx. Now in the next step, we will shift the dy plus 3 from the denominator to the denominator. And we will get here 2y plus 3 whole minus 2 dy. And on the right side, we will also shift 4x plus 5 whole square to the denominator. And you will get 4x plus 5 minus 2 power dx. Now apply integration to both sides of the equality. So apply integration to 2y plus 3 minus 2 divided by the dy is equal to 4x minus 2 dx, integration to this term also. Now as we know that if the derivative of this internal term were present just next to it, so we will just increase the power of this whole term and divide it by 4 and we will get integration. But we will solve this step by supposition. Let t is a variable, it is equal to 2y plus 3 and dt divided by dy is equal to 2. Now in the next step, we will get here dt is equal to 2 dot dy. We just shift dy to the right side and we get 2 dy. Now let's call it equation number 1 and let's call it equation number 2. And let's call this term is term A and let's call this term is term B. Now on the right side, we'll also suppose this term. Let w is a variable which is equal to 4x plus 5 and derivative of w with respect to x is just 4. We'll get dw is equal to 4 dot dx. Let's call this equation number 3 and let's call this equation number 4. Now replace equation 1 and equation 2 and term A above in integration. We will get here integration will replace 2y plus 3 by equation 1 which is t. The whole for of t will is minus 2 dy. On the right side, we'll replace 4x plus 5 by w by equation 3. We will get here w for minus 2 dx. Now we have to change this notation because we have here the variable t and we have the integration with respect to y variable. In this case, the t will be considered as constant, so that's why we have to change this notation dy to dt. And for that, we will multiply a 2 here and we will get 2 dy, and then we will replace 2 dy by dt, and then we will obtain our desired result. I multiply and divide this term by 2. We will get here 1 over 2 integral to t to the power minus 2 and 2 dy. And let's multiply and divide this term by 4. We will get here 4 dx. Now we have to replace 4 dx by equation number 4, which is dw. We will replace 4 dx by dw, and here we have 4 dx. We will replace this 4 dx by dw, and we will replace this 2 dy by equation 2, where is dt. So we will get here 1 over 2 integral to t minus 2. We will get here dt, and on the right side we will get here w minus 2 not dw. Now let's apply integration. So we will get here 1 divided by 2 multiply by the integration of t whole to the power minus 2 is t minus 1. We'll increase the power of t by 1. So here the power of t is minus 2, and here the power become minus 1 because the power is increased by 1. I'll divide this by that power. Right side, you will also increase the power of w by 1. It will become minus 1, and we'll divide by that power and plus c, which is a constant of integration. And the next step, we'll simplify these terms. We will get here t to the power minus 1 divided by 2. On the right side, we'll get w to the power minus 1 divided by 4 and plus c. And the next step, we'll shift the t to the power minus 1 to the denominator, for making the power of t is a simple one. 2t is equal to 1 divided by 4 w plus c. Now we have to replace t and w by equation 1 and 3, and we will get here 2. The equation 1 we have supposed t is equal to 2y plus 3. We have to rewrite the value of t, 2y plus 3 is equal to 1 divided by 4, and we have to replace w by equation 3, which is w is equal to 4x plus 5. 4x plus 5. Now this is the general solution of the given differential equation. For 4x plus 5 plus c. This is the required general solution of the given differential equation. Thank you.